The Cat 1693 wasn't built for comfort. It wasn't designed to be easy to install or quiet on the ears. It was built to work. And in the era of mechanical diesels, that meant building something you could beat on for hundreds of thousands of miles without flinching. For Caterpillar, that meant thinking big. The 1693 was one of the boldest designs they ever put on the road. At first glance, the 1693 might seem like just another old-school diesel. Inline 6, turbocharged, and built like a bank vault. But this engine used design features that stood out in the diesel world of the 1960s. The most unusual was its dual overhead camshaft setup, a significant rarity for a heavy-duty truck engine back then, and even today remains uncommon in the class. Most truck engines used a single cam buried in the block, pushing rods up to rockers. Not the 1693. Cat mounted not one, but two camshafts up top, one for intake and one for exhaust. It allowed for more accurate valve timing, better airflow, and tighter tolerances across the board. This was race car tech applied to long-haul work, and while it added weight and complexity, it paid off in performance and reliability. With those twin cams driving big valves, the 1693 could breathe better than almost anything else on the market. And it needed to. This engine displaced 893 cubic inches, or 14.6 liters, of iron-fisted torque. That kind of size gave it serious low-end grunt, perfect for hauling heavy loads up long grades without downshifting every mile. Unlike a lot of modern diesels that like to rev, the 1693 made its power down low and steady, the way most old-school operators liked it. Its inline 6 configuration helped too. Inline 6s are naturally balanced, which usually makes them smoother than V8s of the same size. But smooth isn't the word most drivers use to describe the 1693. Because despite that balance, this engine still shook hard. The sheer mass of its rotating parts, combined with that big turbo and old-school mounts, meant the 1693 had a personality. You didn't just hear it, you felt it. Internally, the 1693 was all mechanical. It used a unit injector system with injection timing fundamentally set by a dedicated camshaft lobe for each injector. Fine-tuning of valve lash and injector settings were done manually, often with a wrench and a feeler gauge. There were no sensors, no electronics, no computers to crash. If something went wrong, you figured it out with your eyes and ears. And while that meant more hands-on work, it also meant more control. You could tweak fuel delivery and governor settings without touching a laptop. Of course, all that steel came at a cost. This engine was massive, tipping the scales around 3,500 pounds fully dressed. That's heavier than a modern V8 diesel and transmission combined. Installing one in a truck required beefed-up motor mounts, extra bracing, and in some cases, a reinforced front axle just to keep the balance right. But for operators hauling 80,000 pounds through the mountains, the weight was worth it. The turbocharger setup on the 1693 provided essential forced induction across its working range, particularly under load. While naturally aspirated variants of similar Caterpillar engines existed, the 1693 for road-going applications was almost exclusively turbocharged due to its high power targets. Paired with the engine's massive displacement and long stroke, the turbo helped maintain power at altitude and under strain, essential in the Rockies or up north. And Cat didn't stop there. They offered variants like the 1693 TA, which added aftercooling to further control intake temperatures and increase efficiency. But the real secret sauce in the 1693 was its pre-combustion chamber design. Rather than injecting fuel directly into the main cylinder for immediate ignition, the 1693 first sent it into a small chamber where combustion began. This initial burn then shot into the main cylinder and pushed the piston down. The result was somewhat cleaner combustion compared to contemporary direct-injected engines, contributing to reduced particulate matter and softening the combustion event. that not only helped with smoother operation but also reduced stress on the pistons and head. That unique combustion process didn't just help with efficiency, it gave the 1693 a sound unlike anything else on the road. This engine didn't purr or growl, it rattled. Sharp, metallic, and unmistakable, the sound came from a mix of tight mechanical tolerances, the distinct pressure spikes of its two-stage combustion event, and the kind of energy that felt more like a strike than a burn. You could hear it coming long before it crested the hill, and once the engine turned over, you didn't just hear it, you felt it. That's what earned it the nickname Rattlepillar, a name born in truck stops. Definitely not marketing meetings. That rattle wasn't one single noise, it was a layered experience. The combustion chamber gave the engine its sharp edge, but the rest came from the way everything moved. The mechanical valve train and fuel injection system made their presence known with a constant click, especially when the engine was cold. Gear-driven components, timing gears, water pump, fuel pump, air compressor, all spun in tight synchronization, but they weren't quiet about it. They howled, buzzed, and groaned under load, and every bit of it came through the cab. The 1693 wasn't designed to keep quiet, it was designed to get the job done, and the sound was just part of the deal. The mounting setup didn't help. The engine was bolted in with stiff mounts that offered only limited rubber isolation. Not much to soak up vibration. No serious sound insulation in the cab. If the engine was working, you were hearing every bit of it. Long-haul guys joked that you didn't need a gauge to know how it was doing. Just open the vent, listen close, and trust your gut. Then came the turbo. It wasn't subtle. Unlike today's turbos, which are tuned for smooth boost and quiet operation, the 1693's turbo sounded like it came from a farm implement. When it lit up, it laid a high-pitched whistle over an already mechanical grind. And because this engine was built for raw, unfiltered pulling power, not fuel efficiency or refined acoustics, that sound didn't fade out with speed. The harder it worked, the louder it got. At idle, the truck didn't sit still. The whole thing shook. Mirrors buzzed, dashboards flexed. Screws slowly backed out of trim panels. Some drivers carried a small toolkit just to tighten everything back down at rest stops. Others gave up and let it rattle. Either way, the 1693 had a presence. You didn't just drive it, you dealt with it. But despite all that, or maybe because of it, drivers connected with the engine. It gave constant feedback. You could feel what it was doing, hear how it was running. Some operators didn't need to watch their tack. They could shift by sound. They listened for the turbo, the tone of the rattle, the vibration through the seat. It wasn't subtle, but it worked. Even now, long after the last ones left the line, that sound still draws attention. Restorers seek them out. YouTube is full of startup clips and idle footage. Guys will watch a cold start just to hear the rattle. Because for the ones who remember, and even for those who don't, there's still something about the way it sounds. Ask anyone who ran one back in the day and they'll have a story. A dashboard that wouldn't stop buzzing. A mirror that never stayed put. A week-long run where the shake never let up. And most of them will grin when they say the name. There were quieter engines. There were smoother rides. But there was only one Rattlepillar. For all its brute strength and mechanical charisma, the Cat 1693 had flaws you couldn't overlook, especially if you were the one turning wrenches or paying the fuel bill. Some of its problems came from the same bold choices that made it stand out. Others came from being a product of its time, when emissions didn't matter and efficiency took a backseat to durability. The biggest issue was complexity. As mentioned earlier, the 1993 used a dual overhead camshaft design, an unusual choice for a heavy-duty diesel. The same traits that made it powerful and memorable, its weight, noise, and intricate mechanics, also made it impractical in a changing industry. Valve adjustments were more involved. Camshaft timing had to be set precisely, and improper maintenance or wear could lead to serious issues. Mechanics familiar with traditional pushrod diesels sometimes struggled with the layout. And if you didn't keep up on maintenance, the engine would let you know quickly. That mechanical complexity extended beyond the cams. Everything was gear-driven, and everything was mechanical. That meant no diagnostic software, no fault codes, and no easy plug-in solutions. If the engine misbehaved, you had to figure it out the old-fashioned way, with gauges, wrenches, and experience. That appealed to a certain kind of operator, but it made the engine intimidating for newcomers or shops, unfamiliar with CAT's way of doing things. And then there was the vibration. We touched on it earlier, but it deserves a second look, because it wasn't just about comfort. That constant shake took a toll on everything around it. Bolts loosened. Mounts experienced accelerated wear. Wiring fatigued. Some drivers accepted it as part of the experience, but over time, it added to the cost of ownership. If you didn't stay ahead of the wear, the engine could start shaking its own truck apart, one bracket and wire at a time. Another problem was cold starting. The 1693's pre-combustion chamber design helped with smoother operation, but it also made the engine harder to light off in winter. Fuel had to ignite in a small chamber before reaching the main cylinder, which made it difficult to generate and retain enough heat for ignition during cold cranking. In northern states and Canada, drivers leaned heavily on ether, block heaters, or auxiliary tricks to get the engine fired up. And if those didn't work, neither did your schedule. Fuel efficiency wasn't a strong suit either. Compared to direct-injected engines from Detroit or Cummins, the 1693 burned more diesel under the same load, especially on long highway runs. That wasn't a big deal when fuel was cheap, but by the late 1970s, rising prices made a dent in the balance sheet. Fleet managers started paying attention, and the 1693's thirst didn't do it any favors. Then there was the weight. At over 3,500 pounds installed, the engine put real stress on front axles and suspension systems. As truck designs evolved to carry more payload with less curb weight, the 1693's bulk became a liability. It often required reinforced mounts or custom brackets to stay in line. And while it delivered the torque, that extra mass didn't always translate to profit, just more strain up front. But perhaps the biggest nail in its coffin came from the industry itself. As emissions standards started to tighten in the late 1970s and early 80s, older mechanical engines like the 1693 began to show their age. The pre-combustion design wasn't ideal for emissions control, and its overall architecture made compliance tough. CAT saw the writing on the wall and phased out the 1693 in favor of the more modern, though initially still mechanical, 3406 series. While the 3406 would later adopt electronic controls, even its early versions were more efficient, better suited to new regulations, and easier to support. Once the 3406 arrived, support for the 1693 began to dwindle. Parts became harder to source, younger mechanics trained on newer platforms, and even CAT seemed ready to move on. By the late 80s, the engine that once shook mountains was being pulled from service or sidelined as a project motor. That doesn't mean it wasn't respected. Plenty of operators stood by it, even as it became a relic. But respect doesn't always pay the bills or pass an emissions test. By the time the CAT 1693 was phased out, it had earned a reputation as one of the toughest engines to ever hit the highway. But its story didn't end when production stopped. Today, decades later, it continues to live on. You'll still find working 1693s in limited use, especially in rural and industrial settings where reliability matters more than compliance. Some older logging trucks and oil field rigs still run them, particularly in areas with relaxed emissions enforcement, or where operators have the resources to maintain their own fleet. These aren't daily drivers anymore, but when something heavy needs to be hauled, the 1693 is still a viable choice. More commonly, you'll find these engines in the hands of enthusiasts and vintage truck owners. Many live on in private collections or under the hoods of show trucks, often Peterbilts or Kenworths from the 1970s, restored and roadworthy but rarely used for heavy hauling. Instead, they're preserved for short-haul drives, truck meets, or simply the satisfaction of firing one up and hearing that unmistakable rattle again. Online, the engine has created a second life. YouTube channels dedicated to diesel history, truck restorations, and cold starts have helped preserve the 1693's reputation. Search for startups, and you'll find countless videos showcasing everything from raw engine noise to full overhauls. For many viewers, especially those who grew up hearing one, the sound alone is enough to bring back memories. Parts support has become more difficult over the years. While Caterpillar no longer manufactures key components, a handful of aftermarket suppliers still produce gaskets, injectors, and rebuild kits. Some engine shops specialize in vintage cats and keep core parts on hand, but sourcing replacements can involve scouring forums, auctions, and even junkyards. Rebuilds aren't cheap either. A full overhaul on a 1693, if done properly, can cost anywhere from $10,000 to $25,000, depending on condition and availability of parts. But for many owners, it's worth the expense. They're not just maintaining a machine, they're preserving a chapter of diesel history. For younger truckers, the 1693 can be a mystery. It doesn't behave like modern diesels. It doesn't sound like them, or respond like them, or even start like them. But for those who've driven or wrenched on one, it remains unforgettable.